Okay, so this is a complement to Andrei Karpathy's lecture Neural Networks from Zero to Hero. And basically I've taken the micrograph from scratch and just added a couple of additional functionalities to it for better idea visualization. So first of all, I've added some labels to basically the most important results or parts in the neural network. So for example here, for the training data, I've added a couple of labels, and also for this, sorry, one second. Also for inside the neural network, I've made sure that the parameters in the neural network would have labels on them. So here you can see one training example, a neural network shown. And here we've done also already the backwards call. And you can see that for x11, so this is first training set, first x parameter, it's going to be multiplied with all of these v parameters. So v's are the training weights, and basically here 1 means that it's the first layer multiplier, 2 means it's the second neuron, and 1 means it's the first parameter of that second neuron. And the logic for each parameter applies this way. Okay, so what we're doing here is we're taking this x11, so the first training example, first parameter of x, and as you can see, we are multiplying it with what 4 times? 4 times, it means with all the neurons there are, and we are always multiplying it as a first parameter for each specific neuron. And you can see, like if I now move to x12, which means the second parameter, we will always multiply it with all the neurons, of course, but again now with the second parameter of each specific neuron. So like for example here, you can see we are multiplying it v112, which means it's the first neuron, first layer, but second parameter. And here you can see it's again the second parameter of the third neuron in the first layer. And this is how actually like the result is arrived to. And in the end, as you can see, the steps are quite long, because we are doing also presenting each calculation here as a pairwise thing. Okay, so that's a long run. And you can imagine this is just an example neural network. You can imagine how complex OpenAI systems are. So here you can see that this is powered by 2, actually the result of the cost function. So here we have calculated with 10h the last neuron result, and we are now, the cost is actually, we are multiplying y with -1 and adding it to it to get the cost, and then we are powering it up to 2 to get the final cost. And this allows very easily to see, and why I've added also this thing called, the root is quite long. Why I've also added this grad updates is to kind of exemplify a little bit better how this backpropagation works when you have many training samples. So in this case, we have, as shown, 1 training example. But now when you've had here, let's say, 2 training examples, we can see that basically V is going to be updated when we are doing the gradient update 2 times. And this is basically for each result that we actually involves in. So what we mean by this is that we are updating the gradient for each forward pass we do. We need to do like a backwards pass as well for each of the specific weights we are training at right now in this example. Like if you look at V here, this only is in the whole forward pass multiplied with one training data. But here you can see, let's for example, the first neuron, first layer, first parameter. And this parameter V is multiplied now, first of all, with x11, and then it's multiplied also, like in the case of two training examples, it's multiplied now with x21, so with two training examples, which means also that when we are doing this backward pass here from this place, basically we will need to always update the gradient twice. We're doing once here to get the backward pass, basically take the derivative of this multiplication, and we're going to add this here. And now we also do the v11 gradient update from here as well, from this function, or for not this function, but this function actually. So yeah, this is a bit more involved example of the neural network.